In this session, we will discuss about Hamiltonian circuit, which is again an application of backtracking method. What is the problem statement? If you are given a graph with set of vertices and edges, and the graph be connected with all the vertices, a Hamiltonian circuit is a round trip path along certain edges of the graph that will visit all the vertices exactly once and returns to the starting position. So the problem is stated as we need to find all the Hamiltonian cycles in a connected graph G. We will apply backtracking solution to find the Hamiltonian circuit in a graph. So consider this as a graph. We have almost 8 vertices and they are connected to some of the vertices as depicted in the figure. Here are the steps to be followed to find whether a Hamiltonian circuit for the graph exists or not. The first step is to consider a vertex as the source vertex that can be any of the vertices given. Next step is to find its adjacent vertices and explore the legitimate option in it. So we need to explore the adjacent vertices of a selected vertex and explore whether it is legitimate option or not. And the third step is we will continue the above step, that is the second step, until all the vertices are visited and we reach back to the source vertex. Otherwise, we will use backtracking and replace another option from the previous component. So you will get a better understanding if we see this example. Find the Hamiltonian circuit of the following graph. This is the graph which has 5 vertices, 1, 2, 3, 4, 5, and the edges between those vertices are also represented. Initially, assume we are starting out with the vertex 1. So this 1 serves as my root. Next, I will choose all the vertices which are adjacent to 1. So adjacent to 1 are 2, 3 and 4. So based on numerical order, we will visit 2 from 1. So 1 is connected to 2, 3, 4 and now we will start exploring 2. Since we are following a backtracking method which uses depth first traversal, we should not visit 2, 3 and 4. 2, 3 and 4 should not be visited because that will happen in breadth first search. In depth first, we have to explore depth wise. So from 1, I am exploring 2. 2 is connected to 1, 3 and 5. But 1 is already visited, explored. It is the root node. So I will leave 1 and start exploring 3 and 5 as adjacent nodes of 2. So from 2, 3 and 5 are the possible options and now I am exploring 3 and not 5 as we follow depth first. From the figure we can infer 3 is connected to 2, 4 and 5 but 2 is already explored. So we will start exploring only 2 options, 4 and 5. So of this 4 and 5, we will explore only 4 and leave this 5. 5 is selected and 5 is connected to 2, 3 and 4. So 2 has been already explored, 3 has been already explored and while exploring 5 only it ended up with 5. So from 5 we cannot reach back the initial vertex 1. So there is no possibility of Hamiltonian cycle when this path is explored. So from 1 we have traversed to 2, then 3, then 4, then 5. Since 5 is not connected to 1, this is a dead end and this doesn't result in a Hamiltonian cycle. So at this time we backtrack. So we go to 3 because we have already explored 4. From that only we came to 5. So we will backtrack to 3. So 3 is connected to 2, 4 and 5. So already 2 has been visited. So and 4 has been explored already. Therefore 5 is selected as adjacent to 3. So this path I am exploring. 5 is selected as adjacent to 3. And from 5 we can go to 2, 3, 4. 2 is already explored, 3 is already explored. So the only option left is 4. So from 5 I will go to 4. And now let us explore 4. 4 is connected to 1 and 5. So there is a path from 4 to 1 which is our source vertex. So from 1 I will go to, from 4 I will go to 1, which is my starting vertex. So there is a Hamiltonian cycle. If I travel from 1 to 2, 2 to 3, 3 to 5, 5 to 4 and 4 to 1. So this is how I will find out whether a Hamiltonian cycle is available in a graph or not. So for a single graph, there may be one or more Hamiltonian cycle. We apply the same step for all other unexplored nodes to find out the existence of any other Hamiltonian cycle. So here comes the algorithm of Hamiltonian cycle. So every time we need to find out a next node using this function next node that will either return true or false. If it is true, then we will explore that particular vertex. If it is false, we will stop exploring that particular vertex. So here is the function for the next value. In that, we will be checking whether there is an edge and the edges are distinct, meaning the vertices should not be explored previously. And if that is the case, it will return true. And if it returns true, then the vertex will be included in the solution set. If it returns false, the vertex will not be included in the solution set. So analysis, if all the vertices are explored in a straightforward way by using brute force technique, that is naive algorithm, then the complexity of the approach will be n factorial. If backtracking approach is used, then also the complexity doesn't improvise. It is also order of n factorial. Then the number of Hamiltonian cycles that can be created in a graph is given by the formula n minus 1 factorial divided by 2, where n is the number of vertices. Hope you are clear with the Hamiltonian cycle problem using backtracking. Thanks for listening.